Welcome. So we're going to graph another rational function. All right, so first thing we're going to do is factor completely. All right, so A is 1, B is 1, and C is -6. 1 times -6 is -6. We need two numbers that multiply to give us -6, but add to give us our B term of 1. All right, and so that's going to be -2 and 3. All right, -2 times 3 is -6. -2 plus 3 is 1. So we have x squared minus 2x plus 3x minus 6. Right? We rewrite that x as the sum of those two values we found in the step above. Right? So we rewrite that as -2x and 3x. All we've changed is its form, not its value. And the first two are a group and the second two are a group, and we always have plus in between them. Now we plot a greatest common factor. So greatest common factor for x squared and 2x is x. Divide both by x and we will have x minus 2. Greatest common factor for 3x and 6 is 3. If we divide both by 3, we have x minus 2. And then we can factor the repeating x minus 2, and we're left with an x plus 3. All right, so we can rewrite that, the numerator anyway, as x minus 2 times x plus 3. How about the denominator? All right, so let me see if I can squeeze the factoring over here. All right, so we can plot a greatest common factor. Notice that 3x squared and -12 are divisible by 3. So if we factor out of 3, we'll be left with x squared minus 4. But hey, we know how to factor x squared minus 4. I think we saw it on the last video, right? It's square root minus square root plus square root. So this would factor to 3 times x minus 2 times x plus 2. So now let's rewrite the denominator in factored form. So we have 3 times x minus 2 times x plus 2. All right, and so if you notice, we have some repeating factors. We have an x minus 2 in the numerator and an x minus 2 in the denominator. So now let's cancel those and rewrite this in reduced form. So f of x equals x plus 3 times, over 3 times x plus 2. And we can distribute the 3 if you'd like. All right, so, and maybe it makes it easier to find the horizontal asymptote. So f of x equals x plus 3 divided by 3x plus 6. All right, so that's the function we're going to work with, the reduced one. But we're going to remember that we canceled an x minus 2 because that's going to create a hole. All right, so I have it written over there, but I'll write it over here as well. So vertical asymptote, we set the denominator equal to 0. And it's the denominator of the reduced function. So 3x plus 6 equals 0. Subtract 6, we have 3x equals -6. Divide by 3, and x is -2, and that's our vertical asymptote. Horizontal asymptote, actually I'll switch colors. So the horizontal asymptote, notice that the degree of the numerator is 1 because we have an x. The degree of the denominator is 1 because we have an x. So they are equal to one another. So now the horizontal asymptote is just going to be the ratio of the coefficients. Right? So y is going to be equal to 1/3 is going to be our horizontal asymptote. All right? So since n equals m, it is the ratio of the coefficients. I don't think I can put the word coefficients in there. Let's also find the x-intercepts and the y-intercept. All right, so for the x-intercept, set the numerator equal to 0 because a fraction equals 0. where the numerator is 0. So if we set the numerator x plus 3 equal to 0, x equals negative 3. So negative 3, 0 is the x-intercept. How about the y-intercept? We can find the y-intercept. So for the y-intercept, set x equal to 0. So if we set x equal to 0, we have f of 0 equals 0 plus 3 divided by 3 times 0 plus 6. Oops, missing my parentheses there. So that would just be 3 over 6, or 1/2. So the y-intercept is 0, 1/2. So now we already have 2 points, and we only have one, and a hole, and we only have one vertical asymptote, so we don't need that many points. Let's graph this on the next page. Let's just remember everything we have. We have a vertical asymptote, x equals negative 2, horizontal asymptote at y equals 1/3, x-intercept at negative 3, 0, and a y-intercept at 0, 1/2. All right, so let's write everything down here. So first of all, the vertical asymptote was x equals negative 2. So let's graph that. And the horizontal asymptote is y equals 1/3. So I will do my best. About here. It's a little high, but it's really hard to hold my hand steady at 1/3. There we go. I have no lines to look at. Let's label that y equals 1/3. And over here, x equals negative 2. All right, so now we need some points. The hole in the graph was at, what was the canceled value? It was 2, wasn't it? We didn't find the y value of the hole. That's why I can't. I'm like, it's 2 something. All right, we forgot to find the rest of the hole. All right, so there's a hole. Let's put that over here, I guess. And I'll write in, I don't think there's any color I didn't use. I'll write in green. All right, so the hole, right, is at f of 2. So that would be 2 plus 3 over 3 times 2 plus 6. So that's going to be 5/12. So there's a hole at 2 5/12. That's just about a half, actually. So 2 5/12. All right, and let's see if we remember our points. So we had an x-intercept at negative 3. Right, and we'll also use negative 4, so let's just write negative 4 down here. Negative 3 was the x-intercept, so that was 0. Let's just go ahead and plug in the negative 4. All right, so, and we plug it into the reduced one, so that would be negative 4 plus 3 divided by 3 times negative 4 plus 6. So that's going to be negative 1, and that would be negative 12 plus 6, so that's going to be negative 6. So that's just 1/6, right? So that's 1 point. I don't think I want to use anything smaller because it's going to get even closer to the, and if I choose anything further away from that vertical asymptote, it's going to get even smaller, even closer to that horizontal asymptote. So we're good though on the left-hand side. The right-hand side, let's plug in negative 1, and we have 0, 1/2. And then the hole, which was 2 5/12, just a smidge less than a half. And this was a hole. All right, if we plug in negative 1, we have negative 1 plus 3 divided by 3 times negative 1 plus 6. So that's 2. And then that is negative 3 plus 6. So that's going to be 3, so 2/3. All right, so let's graph our points. So negative 4, 1, 6. So that is less than a third. It's half as much as a third. So yeah, I'm going to try to squeeze that in there. And right here, my whoops, my horizontal asymptote is probably a little too low. It's not perfectly straight. I guess that's good enough. That's good enough. All right. And then we have -3, 0. Boy, that's not a lot of points. But I don't want to plug a fraction in. But we know it's not going to cross the vertical. It's not going to cross the horizontal. It's just got one vertical asymptote. It's not going to cross anything. All right, there we go. But it is going to really hug that. And I should not have kicked out again. It's just going to be really close. And of course, it gets closer and closer as x gets closer and closer. As x is as x gets closer and closer to that vertical asymptote, right, it gets more and more negative. So now let's graph our last 2 points. We have -1, 2/3. So twice as much. We have 0, 1/2, which now my line is too high, but I did my best. And then we have a whole, which is a little less than 1/2. I'm going to try to bring down this line a little bit. Oops, no, not the graph, not the graph. Just the line. You know what would be easier probably? Let's fix the line over here. My arm must have been getting tired. Okay. So 0, 1/2. And then a little less than 1/2. And we want to make sure we know that there's a hole there. So let's make sure we put a hole there. There's our hole. So right there is a hole. All right, so we will not cross the vertical. We'll turn for those points, not cross the hole, you'll never be seen or heard from again, and not cross the horizontal. So that's really close to those asymptotes. Domain is up there. So domain is going to be everything but the vertical asymptote and the hole. So x can't equal -1, and x can't equal, excuse me, that's not -1, that's -2. X can't equal -2, and x can't equal +2. All right, so the domain is going to be -∞ to -2, and then -2 to 2, and then 2 to infinity. For the range, we're not going to equal the horizontal asymptote, so y is not going to equal 1/3. And we also can't equal the y coordinate of the hole, so y can also not equal 5/12. 5/12 is almost a half, so that is more than 1/3. So the range will be -∞ to 1/3, 1/3 to 5/12, and 5/12 to infinity. So we're taking out the horizontal asymptote because we didn't cross it, and we're taking out the y coordinate of the hole. And there we go. That's all there was to graphing this one. If the numbers weren't so small, this one would have been really easy. All right, so now we're going to do one other thing, and the last thing for graphing rational functions, and that is just a little review of domain, vertical asymptotes, holes, x-intercept, y-intercept, and then range. These ones will be easy enough to do the range on. The more difficult graphs, we need to see the graph, but these ones, it's okay. All right, so now let's find all of these features. All right, so first of all, you should try to factor whenever possible. So though it's not quadratic, 4x and 16 have a common factor, so let's factor that. So we have y equals x minus 4 divided by, all right, so let's pull out the -4, and that would be x. -16 divided by -4 is a +4. So you see, there's no repeating factor, so nothing's going to cancel out. So no holes, because that didn't cancel out. All right, so let's do the vertical asymptote first. So we just set our denominator equal to 0. All right, so we have, actually maybe I'll switch colors so it's easier to see one thing from the next. So if we set negative 4x minus 16 equal to 0. Now we also could set the factored one. And you notice that might be even a little easier. So negative 4 times x plus 4 equal to 0. Because if we divide both sides by negative 4, of course that's just still 0. So x plus 4 equals 0. X is negative 4. So that is the vertical asymptote. The horizontal asymptote, so I'm not necessarily going to do these in order. The horizontal asymptote, of course, actually, no, we'll do them in order. The x-intercept is you just set the numerator equal to 0. Right? So if x minus 4 equals 0, x equals 4 is the x-intercept. So 4, 0 is the x-intercept. For the y-intercept, just plug in 0 for x. Right? And so we have y equals 0 minus 4 divided by negative 4 times 0 minus 16. So that's going to be negative 4 divided by negative 16, or that would reduce to 1/4. So the y-intercept is 0, 1/4. Horizontal asymptote is the ratio of the coefficients, all right, because they have the same degree. All right, so notice there that, I'll put it over here, I guess, that n is degree 1, right, because we have an x. M is degree 1. We have a negative 4x, but it's just to the first power. So they're equal to one another. So our horizontal asymptote is going to be just the ratio of the coefficients. So y equals 1 divided by negative 4. That's negative. So you can put 1 over negative 4 or negative 1/4. It doesn't make a difference. All right, so continuous, discontinuous is not something we've really gone over, but well, actually we did talk about it when we started graphing with two vertical asymptotes, and we talked about if we didn't pick our paper off the pen, if we didn't pick our pencil off the paper, and we could draw the graph, that would be a continuous graph, just sort of informally defining it. And we had a graph. If you look back to the very first graph where we got to where we had squared terms, we had a graph that was continuous. So a graph that was continuous would have no holes and it would have no vertical asymptotes. So this graph has a vertical asymptote. So therefore this graph is not continuous. So this is discontinuous. And specifically, we have an infinite discontinuity because there's a vertical asymptote. All right, so now let's just find the domain and range. So the domain is going to be everything but the vertical asymptote. So negative infinity to negative 4. And, oops, wait, am I looking at the right one? Yes, and negative 4 to infinity. Okay. And let's see. We need the range. So this graph is not going to cross the horizontal asymptote. So, because if the graph doesn't have anything squared, and it's just an x or just a constant, then it's not going to cross the horizontal asymptote. So this range is negative infinity to, we'll skip over negative 1/4. And then negative 1/4 to infinity. All right, now let's try the next one. All right, so first of all, let's try to reduce that. And that's an easy factoring. Right? We got a difference of squares, so that'll be square root minus square root plus square root. And oh, look at that, we can cancel something. We can cancel the x minus 3's. So in reduced form, this function is y equals x plus 3. So now we don't have any denominator. All right, so that means we have we have no vertical asymptote. So this is none. There's no denominator left. But we do have a whole, right? We canceled out that factor. So that means we have a whole at x equals 3, right? Because we set that equal to 0. What's the y value of the whole? Just plug it into the reduced one. So that would be y equals 3 plus 3, or 6. So we have a whole at 3, 6. Okay. All right, so we can find the x-intercept and y-intercept. This time we won't have a numerator set equal to 0. We'll just set the whole thing equal to 0. So for the x-intercept, 0 equals x plus 3. So subtract 3 from both sides. And negative 3, 0 is the x-intercept. To find the y-intercept, just plug in 0 for x. So we have y equals 0 plus 3. So 0, 3 is the y-intercept. All right, we canceled out the denominator. So if we don't have a vertical asymptote, we don't have a horizontal asymptote either. So this is none. This is just a line, right? We graphed one like this. This is just a line with a hole. This is, however, not continuous. It is also discontinuous, not because it has a vertical asymptote, but because it has a hole, right? And so it has a point discontinuity. So from the domain, we're going to have to take out that hole. So this will be negative infinity to 3, 3 to infinity. And from the range, we're going to have to take out the y-coordinate of the hole. Right? Because if x can't be 3, y can't be 6. So negative infinity to 6 and 6 to infinity. So that's it. We're all done. That's the end of my podcast and the last of my graphing rational functions. So thanks for watching. Bye for now.